Everyone, in this video, we're looking at network device access control and infrastructure security. So these are some of the ways where we can control access to our network devices. So the first method is the access control lists. So ACLs are sequential list of access control entries or ACEs. And these entries have either permit or deny classifications based on predefined conditional matching statements. So as the name implies, when we have sequential list, so it starts from the top of the list and proceeds down according to the sequence number. Each of the statement have conditions and the rules should be matched. When a match is found, the appropriate action, either permit or deny, will be taken. Once a match is found, this processing of the sequential entries will stop. At the end of every ACL is an implicit deny, which denies all packets that did not match earlier in the ACL. So there are many ways yang kita boleh implement access control lists. First, we have standard ACLs. The second is extended ACLs. So these two, standard and extended, can be implemented either using numbers or name. So usually human beings, they understand more using name because it's more descriptive. So you can use name ACLs, but you can also use number. Untuk standard ACL, the numbers are ranging from 1 to 99 and 1300 to 1999, while the extended numbered ACL is using numbers 100 to 199 and 2000 to 2699. Other access control lists are port ACLs and also VLAN ACLs. So compared to the standard and extended ACLs, which uses source and destination IP address as well as source and destination port numbers, the port ACL are specifically filtering based on MAC ACL or at layer 2 switch ports, and VLAN ACLs can filter based on VLANs. So untuk kita letak condition dalam ACL, kita akan gunakan wildcard mask compared to subnet mask untuk destination network. So wildcard mask adalah simple. It is basically the inverse of the subnet mask. So kita boleh gunakan konsep pengiraan subtract kita punya subnet mask daripada 255.255.255.255 untuk kita dapatkan wildcard mask. What's important in implementing an ACL is the application, which means kita kena applykan sesuatu ACL kepada a particular interface. Kalau kita tak applykan ACL ini kepada interface, it will not take action. Dalam application ACL kepada interface, kita mesti specify the direction inbound ataupun outbound of that particular interface. So Cisco allows one inbound ACL and one outbound ACL per interface. Let's look at the numbered ACL first. So the process of defining a numbered ACL is using the command access list and the number. So the number can be between 1 to 99 or 1300 to 1999. And then after that, we specify whether it is a deny or a permit statement. And since it's a standard ACL, we only use the source destination address, the source address and also the source wildcard. Once we have the ACL, we apply the ACL to an interface using the command IP access group and the ACL number and the direction whether in or out. So in ACL, we have some keywords that can replace or as a shortcut certain source addresses. For example, kita ada any, which is basically matches all packet, ataupun kita nak match hanya satu, a specific IP. So kita gunakan keyword host. Ini satu example numbered standard ACL. So access list ini menggunakan number. So number contoh di sini adalah 1. Kemudian dalam access list 1 ini kita ada beberapa ACE. ACE yang pertama is deny 172.16.0.0 and the wildcard mask is 0.0.255.255. So the ACE yang kedua adalah deny host 192.168.1.1. So host ini mewakili source address 192.168.1.1 dan wildcard mask dia adalah 0.0.0.0. That means dia mesti match IP 192.168.1.1. Kemudian kalau kita tak letak permit any, okay, dalam ACE ini kita akan ada implicit deny, which means selepas statement 1 dan 2 kalau tak jumpa match dia akan deny semua. Untuk prevent berlaku deny semua ni kita kena letak permit any. Okay, so maksudnya deny alamat ini, deny alamat ini dan yang lain kita bagi lepas. Sebab kalau tidak, dekat ujung setiap ACL akan ada implicit deny. Okay, now after we have listed all our ACEs, we apply this ACL into an interface. In this example, it is gig 1/1. We use IP, access group, and the number and the direction. So in this example, it is inbound. Format untuk extended numbered ACL adalah lebih kurang sama macam standard numbered ACL, cuma number dia adalah berbeza from 100 to 199 or 2000 to 2699. So since it is an extended ACL, it will have a source and also destination, IP address or source and destination port number. So example di sini adalah kita boleh gunakan extended ACL untuk deny traffic daripada telnet. So here example dia menggunakan port number 23 for telnet and also we use ICMP traffic untuk specify ICMP. So dekat ujung ACE, kita akan letak permit IP any source and destination. Okay, untuk kita override deny any. Kalau nak gunakan name instead of number, so instead of kita letak number, kita letak sama ada ia adalah standard or extended and then the ACL name. After that, we put the sequence number and then the ACEs, either permit or deny statements. Dan cara apply juga menggunakan keyword IP access group. So here's one example, IP access list standard. Kemudian namanya, contoh nama is standard ACL. And then we put the sequence of ACEs of deny or permit statements. Next, we have port ACLs, which are access lists that are applied on layer 2 ports. So this PACL can be standard, extended, or named IPv4 ACL untuk layer 3, but also can be for layer 2. So ada beberapa restriction untuk PACL ni. Depending on what platform that you are using on the device. Satu, PACL only support incoming traffic, so there's no filtering for outbound traffic. Next, you cannot filter control packets. Okay, control packets ni adalah contoh untuk management lah, contoh CDP, VTP, DTP ini adalah protokol yang kita gunakan untuk manage layer 2 switches. So kita tak boleh filter these kinds of protocols. Then PACLs are supported only in hardware because it is port based, and it does not support filter for IPv6, ARP, or MPLS. Okay, so how do you apply to a port? So basically here, contoh when you apply, konsep dia masih sama, tetapi kita gunakan konsep switch port. So that means we are applying it to a layer 2 switch port. We can also filter traffic based on VLANs. So in this case, we call it as VLAN ACL. So the communication between traffic inside a VLAN or between two different VLANs can use the VLAN ACL to filter the traffic between them. So untuk implement VLAN ACL ni, kita gunakan keyword VLAN access map. And it is quite similar to route map where we have a match statement and then an action statement. To apply the VLAN ACL, we use the keyword VLAN filter. So first we create an access list. For example, here, there is an access list called ICMP, and we want to allow any ICMP traffic. Next, we create a VLAN ACL. So for example, here, VLAN access map VACL20, and we want to match the IP that is set in the access list called ICMP. That means we want to match any ICMP traffic. And what is the action when there is a match? The action is drop. So instead of if we use the ACL, we can use permit and deny. So here sebenarnya kita nak deny traffic that is coming from ICMP, and another example is Telnet. But when we use VACL, we only use permit statement in the ACL, and then we deny it by using the action drop. The other action is forward. So for example here, ACL called other permit IP any. So this is for any other traffic besides ICMP and Telnet, and if it matches, we forward the traffic. So let's look at how we want to secure our devices. The most basic one is using password protection. This can be used to control or restrict access to the command line interface. So there are three basic methods where we can gain access to the command line interface for our devices. The first one is through the direct physical connection using the console line. The next one is by remote connection. Yang ni kita gunakan auxiliary port ataupun the virtual line. So the virtual line or virtual terminal is used specifically for Telnet and SSH connections. So untuk kita protect this access untuk CLI ni, untuk kita prevent unauthorized access and unauthorized changing of configuration, we can use password protection. One is password configured directly on the line ataupun directly onto the iOS. The second one is using a username based authentication. So this is recommended as a fallback. Maksudnya backup sebelum kita gunakan AAA server. So if we are using password, so Cisco does specify 5 different password types. So basically it is based on a level of security lah. Okay, so type 0 passwords are the most insecure because they are not encrypted, and it will be visible in plain text kalau kita view the device configuration. So example password yang type 0 adalah bila kita buat basic device configuration menggunakan keyword enable password. Kalau kita nak secure sikit lagi, we go up a level which is type 5 password, and we use the keyword enable secret. So enable secret melambangkan that it has a Cisco proprietary encryption. Indicate security lah untuk the password. Next is type 7 password, where we use the cipher encryption algorithm, and the keyword for configuring this is service password encryption. Another level of password is type 8. This is using hash function and is considered to be uncrackable. Next is type 9 password, also using hashing algorithm. So dari segi configuration, we can relate these levels or the type of passwords based on what kind of keyword that we use. So if we use the command username and password, this is basically a plain text password or type 0. If we use the keyword secret, then it provides type 5 encryption. And if we want to have a more secure password, we use the algorithm type and indicate whether it's a MD5, hashing a SHA-256 or script algorithm. And so ini akan provide type 5, type 8 or type 9 encryption. So the third set of commands is the highest level of password encryption, and it is recommended. So back to how we can configure the password protection, ada 3 level. Satu, directly on the line. Yang kedua, gunakan username based authentication. Dan yang ketiga, gunakan a AAA server. This is how we configure on a line for the password. So basically, we state which line that we are configuring. For example, line console, the auxiliary, or the virtual terminal. And then we set a password to that physical line. So we need to use the keyword login to make sure that this password check-in is available at the respective lines. Next, we can enable username and password authentication or name-based authentication. So basically, we use the keyword username and its respective password for each username. And then on the different lines, we use the keyword login local. What this does adalah bila kita nak access daripada the different line, it will ask for a username. So berbeza dengan password authentication saja, where it directly asks for the password. For local username and password, it is having a pair of username and the respective password. So based on the username and password pair, we can also assign privilege levels. That means a particular user can be escalated to a certain type of level in the iOS access. So privilege level 0, basically kita hanya boleh run the commands disable, enable, help, log out and also exit. So this is the lowest level lah, hanya untuk kita run these 5 commands. Next, we have privilege level 1. This is known as user exec mode. So anything that you can do after the sign greater than. So kita tak boleh configure lah. Untuk configuration, we need to be at privilege level 15, which is the highest level. So we can define this privilege level when we define the username. So example kat sini, username dia Nox. And we create a password of type 9, the highest hashing password. Okay, and then kita bagi kat dia privilege level 5. So level 5 allows the user to go into any interface on the router and shut it down or unshut and configure an IP address. So macam yang disenaraikan dekat sini. So salah satu cara where we can remotely access our devices is through the VTY lines. So since kita akan gunakan basically remote networks lah ataupun public networks untuk access the devices, we can filter the traffic by using the ACLs. So, untuk apply ACL dekat line VTY, kita gunakan keyword access class and it's usually applied to the inbound traffic lah. So, the example here adalah kita create satu access list. So, this is a numbered access list and we deny one particular IP and permit all other IPs. And then this access list is applied to the line VTY in the inbound direction. So, since VTY line ni, kita boleh access sama ada menggunakan telnet ataupun SSH. Kita boleh strictkan lagi access dengan menggunakan command transport input. So, katalah we know that telnet is insecure because it's plain text. We can enforce that the input line can only use SSH dengan gunakan keyword transport input SSH. So these are the capabilities of the keyword lah. So as you know, SSH has currently two versions, version 1 and version 2 lah. So version 2 is the stronger version of the SSH. So this is the configuration for SSH access online VTY. So you need to generate the crypto key. The third method for authentication is by using a server, and this server implements the framework of AAA or authentication, authorization and accounting. So, langkah yang lebih ataupun paling scalable lah dalam organisation adalah menggunakan AAA server lah, sebab kita boleh gunakan dalam beberapa aspek, which means we can implement the AAA on your network device and also the network access. So the AAA is basically a framework untuk kita implement security function dari segi authentication, authorization and accounting. So framework ini kita gunakan sebagai guideline untuk mana-mana protokol yang nak implement authentication, authorization and accounting ini. So contoh dua protokol yang biasa digunakan adalah Radius and TACAX Plus. Radius, open standards and TACAX Plus from Cisco. Reason why kita bagi dia sebagai framework adalah setiap protokol yang nak implement ni dia mesti support ketiga-tiga. Cuma dari segi implementation, you can implement all three ataupun the individual components of the AAA framework. Jadi dengan menggunakan AAA ni, we can use it for network device access control, which means when you want to access to a local device, the authentication process, instead of you buat save dalam iOS, kita save dekat server. So the authentication is done by the server for all the devices in your organisation. Selain tu juga, the server boleh buat authentication for your access control. That means dari segi privilege and your accounting levels. So TACAX Plus is the protocol coming from Cisco, but it is an open standard and usually it's used for device access control. But since it supports the framework, you can also use for some types of network access. So since TACAX Plus ni protocol coming from Cisco, so dia ada ekosistem dia lah, boleh gunakan Cisco ISE ataupun Identity Services Engine sebagai dia punya platform for users to access the services in the AAA framework. An alternative to TACAX Plus is Radius. So Radius is more commonly used for secure network access sebab dia punya support for EAP. So EAP is a framework for authentication. Jadi dia boleh support beberapa jenis authentication. Contohnya TLS, CHAP, MD5 dan sebagainya. So feature ini tak ada dalam TACAX Plus. Jadi TACAX Plus usually is more used for network device control. These are some other comparison between Radius and TechX Plus. So both of the protocols have the strengths and weaknesses lah. Contohnya Radius does not support network device command line accounting, while TechX Plus does have the support for this accounting. As I said before, Radius supports EAP ataupun port-based authentication. So TechX Plus does not support EAP. Dari segi AAA, TechX Plus separates authentication and authorization, but Radius combines both authentication and authorization. So you have to implement both. Radius only encrypts the password field, while TechX Plus encrypts the entire payload.